What is a black hole? Is it just a hole in space? Is it a star that has gone dark? Is it a portal to another dimension? Or is it something else? The term black hole refers to a region of space where gravity is so strong that nothing, not even light, can escape. Although the term was first used in the 1960s by American physicist John Archibald Wheeler, who popularized it in his lectures and writings, it is a much older concept. In 1915, Albert Einstein published his general theory of relativity, which formed the foundation of modern understanding of black holes. Though he doubted the physical existence of black holes and looked at them as mathematical constructs, he believed that there must be some undiscovered physical mechanism that prevents matter from collapsing into a point of infinite density and zero volume, called a singularity. A year later, Karl Schwarzschild found the first exact solution of Einstein's general relativity, providing a means to calculate the Schuster Radius for non-rotating spherically symmetric objects. This radius signifies the threshold at which an object, when adequately compressed, can transform into a black hole. Even before that, back in the 18th century, John Michell and Pierre-Simon Laplace considered the possibility of stars that are so massive and dense that their escape velocity, the velocity needed for an object to overcome the gravitational pull of the star, exceeds the speed of light. But if these objects don't emit or reflect light off its surface, it must mean they are not visible to our eyes. Then how can we detect them? The first black hole was discovered in the year 1964, and since then several more have been found. The Event Horizon Telescope captured the first image of a black hole at the center of the M87 galaxy, 53 million light-years away, in 2019, and a second image of the supermassive black hole Sagittarius A star at the center of our Milky Way galaxy in 2022. So how do they do it? And what does a black hole look like? Are there different types, shapes and sizes? How are they born? How old is the oldest one that we have found, and how near is the nearest? And finally, did some of them really baffle our scientists by defying laws based on our current understanding of physics? This is Spacetime by Sciencescope, and in this episode, we'll answer all these questions and some more. So please like, share and subscribe to support us in making more such content. Stars are powered by nuclear fusion reactions in their cores, which convert lighter elements like hydrogen into heavier and more stable ones and release energy, creating an outward pressure that balances the inward pull of gravity, keeping the star stable. When it runs out of hydrogen, its main fuel, it starts fusing heavier elements into even heavier ones until it reaches iron, the most stable element. Iron cannot fuse into heavier elements without absorbing energy. The core stops producing energy and has nothing to counteract the force of gravity and collapses rapidly under its own weight. The collapse is halted at nuclear density. The outer layers rebound and explode into a supernova. The core forms a neutron star, or if the original mass of the star was big enough, a black hole. Once formed, they can continue to grow by consuming matter near them, such as gas, dust, or other stars. They can also merge with other black holes to form bigger ones. The supermassive black hole at the center of our own Milky Way galaxy, Sagittarius A star, has a mass of about 4 million suns and around 20 times wide according to some sources. This is huge compared to black holes left behind when massive stars die. But astronomers think there are supermassive black holes at the center of nearly all galaxies. Compared to most of these, Sagittarius A star is meager and unremarkable. The origin of supermassive black holes remains a mystery, with two main theories. The small seed theory proposes that they formed by merging smaller black holes, which originated from collapse of massive stars in the early universe. The large seed theory suggests that enormous gas clouds in the early universe either formed unstable supermassive stars that quickly collapsed into black holes or directly collapsed into black holes without going through the star formation process. The most massive black hole observed so far TON 618, has a mass of 66 billion times that of the Sun and is located at the center of a galaxy more than 10 billion light years away from us. If that doesn't seem far enough, the most distant black hole detected so far is at the center of a galaxy around 13 billion light years away from us, which means we see it as it was when the universe was only 670 million years old. While the nearest one discovered till now is just more than 1500 light years away and is roughly 10 times more massive than our Sun. But it's probably not the closest that exists or even the closest we'll ever find. Most known black holes steal and eat gas from massive companion stars. That gas forms a disk around the black hole and glows brightly in X-rays. But hungry black holes are not the most common ones in our galaxy. Far more numerous are the tranquil black holes that are not mid-meal, and finding them is a difficult task. So how do they do it? A star orbiting a black hole at a safe distance won't get eaten, but it will be pulled back and forth by the black hole's gravity. Scientists can detect the star's motion and deduce the black hole's presence. Astronomers track the orbits of several stars near the center of the Milky Way to prove it houses a supermassive black hole, a discovery that won the 2020 Nobel Prize. When very massive objects accelerate through space, they create ripples in the fabric of spacetime called gravitational waves, some of which can be picked up by detectors like the LIGO observatories and the Virgo interferometer. This method was used to discover multiple black hole mergers, including the largest one detected so far in 2020, that led to the first detection of an intermediate mass black hole. Massive objects like black holes can bend and distort light from more distant objects. This effect, called gravitational lensing, can be used to find isolated black holes that are otherwise invisible. An ultramassive black hole with a mass of about 33 billion times that of the Sun, located in a galaxy cluster about 2.7 billion light years away, was discovered in 2021 by astronomers using the Hubble Space Telescope and computer simulations, making it the first black hole detected by gravitational lensing alone. But what are the different types of black holes that we can find in the universe? Astronomers generally divide black holes into four categories according to their mass: stellar, supermassive, intermediate, and primordial. The mass ranges that define each group are approximate, and scientists are always reassessing where the boundaries should be set. But what are they made of and what do they look like? A black hole has only three properties: mass, spin, and electric charge. They do have several features though that define their structure and appearance. Corona. A corona is a region of hot plasma that surrounds a black hole's accretion disk. It emits high energy radiation such as X-rays and gamma rays. Particle jets. Particle jets are streams of matter and energy that are ejected from near the poles of a spinning black hole. They can travel at near light speed and extend for thousands or millions of light years. Accretion disk. An accretion disk is a ring-shaped structure that forms when gas and dust fall towards a black hole. It rotates around the black hole and heats up due to friction and magnetic fields. Doppler beaming. A Doppler beaming is an effect that makes one side of an accretion disk appear brighter than the other. This happens because the side that is moving towards us appears bluer and brighter due to relativistic effects, while the side that is moving away from us appears redder and dimmer. Photon sphere. A photon sphere is a spherical region around a black hole where photons, particles of light, can orbit in unstable and circular paths. If an observer were inside this region, they would see multiple images of everything outside it due to light bending around the black hole. Event horizon. An event horizon is the boundary that separates the inside and the outside regions of a black hole. It is also known as the point of no return because anything that crosses it can never escape from the black hole's gravity. Singularity. A singularity is the point at the center of a black hole where all matter and energy that fall into the black hole are compressed to infinite density and zero volume. The laws of physics break down at this point, and we don't know what happens inside a singularity. Black holes are truly amazing and mysterious objects that challenge our understanding of the universe. I hope you enjoyed learning about black holes today. If you like this video, please give it a thumbs up and subscribe to our channel for more space related content. Also, don't forget to leave a comment below and let us know if you have any questions or suggestions for future videos. We would love to hear from you. Thank you for watching Spacetime by Sciencescope, and until next time, keep exploring the wonders of the universe. Bye!